Now, this says intersection of two straight lines. Guys, the point of intersection is the only point that is common to intersecting graphs. I think next year when I teach this, I'm going to teach graphs before I teach coordinate geometry. It should make life a lot easier. So the point of intersection is the only point that is common to intersecting graphs. So if you look at these two lines, the diagrams, we have three diagrams, and in the diagram one, we have the line y is equal to x minus 1 being intersected by the line y is equal to minus 2 over 3x plus 4. And you can look and see that is only one point. It is only one point that is common to the two lines. In other words, the one point, the point of intersection, which is 3, 2, is the only point that is on both lines. What I did with the next two diagrams was to separate the two lines to show you that the one point is on the two lines. So the point of intersection is the one point that is the only point that is common to two graphs that intersect. So in the diagram above, 3, 2 is the point of intersection of the lines y is equal to x minus 1 and y is equal to minus 2 over 3x plus 4. The value of x at the point of intersection is x is equal to 3. Guys, what I'm going to do next is I'm going to substitute x is equal to 3 in the two equations. Because when you want a coordinate for a point, when you want the coordinates of a point and you know one of the coordinates, to get the other coordinate, you simply substitute the coordinate that you know into the equation. So we already know the x coordinate is 3. See it here? We can see it for ourselves. This is x is equal to 3, x is equal to 3, x is equal to 3. That's the coordinate at the x coordinate at the point of intersection. So putting that into the two graphs, into the two equation, we get when x is 3, y would be equal to 3 minus 1, y would be equal to 2. Over here, when x is 3, we get y is equal to minus 2 over 3 times x, which is 3 plus 4. This into this is 1. This cancels this. This is minus 2 plus 4, which is also 2. So what we are seeing here, or at the bottom here, this says, this means that at the point of intersection, the y coordinate of intersecting lines are the same. And this only occurs at the point of intersection. At the point of intersection, the y for two graphs that intersect are the same. And this only occurs at the point of intersection. So I'm going to use that knowledge now to determine, the equation, the interpoint of intersection of 2 points. Hear this. Steps for finding the coordinates of point of intersection. 1, make y the subject for both equations. 2, equate the expressions in x for y of both equations and solve for x. Substitute this value of x into any of the two equations and solve for y. State the coordinates of the point of intersection. All right. Just saying that, you might not understand fully what I'm saying, but let me do it and then you should understand better. So there is example 12, which I'm leaving for you. I'm doing example 13. Example 13 says, determine the point of intersection of the linear equations 4y plus 8 is equal to 5x and x plus y is equal to 7. So these two lines, if I drew a graph of the two of them, we would see that the two of them intersect. So the first line is 4y plus 8 is equal to 5x. Let's make y the subject. 4y is equal to 5x minus 8. All I did, positive 8 on the left goes over to the right and become negative. Then I divide the entire equation by 4, not 2, 4. When I do, I'm going to end up with y is equal to 5 over 4x minus 2. Over here, we have y plus x is equal to 7. Now, y would be equal to minus x plus 7. Should I do a sketch of this? I could do a sketch of it to give you an appreciation of what I'm talking about. I could. I didn't have to, but I really want you guys to understand fully why. X 2, 4, 6, 8, 10, 12, minus 2, minus 4. All right. 2, 4, 6, 8, 10, 12. All right, this one cuts the y-axis at minus 2. The gradient is 5 over 4. All right. So this is the line y is equal to 5 over 4x minus 2. The next line is y is equal to minus x plus 7. It cuts the y-axis at 7, and the gradient is 1. The gradient is 1. All right, this is an example of the line y is equal to minus x plus 7. According to my diagrams, this is the y-axis, this is the x-axis. According to my diagrams, the two graphs intersect at the point 4, 3. That's according to my diagram. Let us see if calculation agrees. All right, so let's see if calculation agrees. Now, I need everybody to look and see what I do in order to determine the point of intersection by calculation. So I drew the two graphs to give you an appreciation of what you're being asked to do. You're being asked to determine the coordinates of this point. By observation, just from drawing the graph, this appears to be the point 4, 3. Let us see if calculations agrees. Now, I'm going to use the fact that at the point of intersection, the y's for the two graphs are equal. So at point of intersection, y1 is equal to y2. At the point of intersection, y for the two graphs are equal. Now, y for the first graph is 5 over 4. x minus 2, and y for the second graph is minus x plus 7. At the point of intersection, those two y's are equal. Guys, I'm going to find the LCM, use the LCM, and then discard the LCM. I'm going to determine, so at the point of intersection, these two lines are equal. And this only occurs at the point of intersection. So if I solve this equation, I'm going to get the value of x at the point of intersection. The LCM is 4. 4 into 4 goes 1. 1 times 5x is 5x. Minus 2, 1 into 4 goes 4. 4 times 2 is 8. Is equal to 1 into 4 is 4. 4 times minus x is minus 4x. 1 into 4 is 4. 4 times 7 is 28. So now I have 5x minus 8 is equal to minus 4x plus 28.
Uncle Oral, if you're speaking, your mic is off.
All right, thank you, Joanna. All right, so let's go again. I'm going to start back from here. So this is going to be one of those videos. All right, but we can't do it over. We don't have the time. So this is where we got to before all of the issues. I think next time what I need to do is turn off my phone during class time so people cannot call me. Then now, so I found the LCM. I'm solving an equation with fraction. From grade 10, you should remember one way to do this is to find the LCM, use the LCM, and then discard the LCM, which we have done. So now let's solve. We have 5x plus 4x is equal to 28 plus 8. So we have 9x is equal to 36. Divide both sides by 9, and we get x is equal to 4. But remember, this is everything here is at the point of intersection. So this is saying that at the point of intersection, x is 4. And I'm saying that so far that agrees with our diagram. All right, so this is x is equal to 4. What we need now to do is to get the value of y at the point of intersection. To get the value of y, all I need to do is to substitute this value of x into any of the two equations. These are the two equations. The two equations are here. Y is equal to 4 over 5x minus 2. And y is equal to minus x plus 7. Those are the two equations. Then, so I'm going to say, using this equation, y is equal to minus x plus 7. It doesn't matter which one I use because both of them are going to give me the same answer. I'm going to say when x is equal to 4, because the value of x at the point of intersection is 4, and I'm going to get y is equal to minus 4 plus 7. So y is equal to positive 3. So at the point of intersection, x is 4 and y is 3. So 4, 3 is the point of intersection. So this is how you would use calculation to find the point of intersection. This would be the line y is equal to 3. This is y is equal to 3. So x is 4 and y is 3 are the coordinates of the point of intersection. I'll say it again. You did not need to draw the diagram. I only drew the diagram to give you an illustration of what you are being asked to do. All you need to do is first, 1, make y the subject for the two equations. 2, use the fact that at the point of intersection, y1 is equal to y2. Use that to form an equation, then solve the equation to get the value of x at the point of intersection. Then lastly, substitute this value of x into any of the original equation to get the value for y. Once you have the value of x and the value of y, you have the coordinate of the point of intersection. Guys, I just did example 13. I want you to go back and do example 12. I'll leave 12 up, 13 up. I want you to go back and do example 12. All right, so we're doing example 12, and for example 12, I will not be drawing a diagram. For example 12, we have 3y minus 4x, is equal to 4x plus 3. And example 12 says 3y is equal to 4x plus 3 and y is equal to minus 2x plus 11 are intersecting straight lines. We're to determine the coordinates of the point of intersection. So we need to start out by making y the subject for both equations. So I'm going to divide this equation by 3. And when I do, I'm going to end up with y is equal to 4 over 3x plus 1. The second equation is y is equal to minus 2x plus 11. Y is already the subject. Now at the point of intersection, y1 is equal to y2. So I'm going to use that knowledge to form an equation in x. My equation is going to be 4 over 3x plus 1 is equal to minus 2x plus 11. So I'm going to solve this equation for x. It's an equation with fractions. And from your previous grade, one way to solve an equation with fraction, well, first of all, you have to get rid of the fractions. And one way to do that is to find the LCM, use the LCM, and then discard the LCM. The LCM is 3. 3 into 3 is 1. 1 times 4x is 4x. 1 into 3 is 3. 3 times 1 is 3. 1 into 3, 3. 3 times minus 2 is minus 6x. 1 into 3 is 3. 3 times 11 is 3. So I found the LCM. I use the LCM. Then I'm going to discard the LCM. Discarding the LCM means going forward. I go forward without the LCM. It's supposed to be 33. So I have 4x plus 3 is equal to minus 6x plus 33. So I'm going to have 4x plus 6x is equal to 33 minus 3. 10x is equal to 30. Divide both sides by 10. When I do, I'm going to end up with x is equal to 3. So guys, what this is saying is that at the point of intersection, x is 3. Now, I'm going to substitute this value of x into any of the original equations. So my equation, I could use this one. I could use the other one too, it doesn't matter. Both will give me the same answer. I'm going to say using y is equal to 4 over 3x plus 1. I'm going to say when x is equal to 3, y would be equal to 4 over 3 times x, which is 3 plus 1. 3 cancels 3. So this is 4 plus 1, which is 5. So at the point of intersection, x is equal to 3 and y is equal to 5. So guys, 3, 5 is the point of intersection. All right, guys, never forget this. This is something that you must never forget. You must always remember how to determine the coordinates of the point of intersection of two graphs by calculation.